We wanted to know what everyone else was doing, who's working with fisheries monitoring and fish habitat monitoring, fish population monitoring. But we also talked about what's out there. How do we find out what other people are doing, how they're doing it, and what tools they're using? So I saw a presentation by Jordan Reed who addressed those exact things, and I thought maybe we could get that group to present to us. Jordan had a previous meeting, he couldn't present, so he contacted his co-author, Allison Appling, who's with us today, and Lindsay Carr has worked on this project also. So they're all USGS folks from the Water Mission area, the data science branch. And the reason I thought it was a great little presentation in part is because it showed how they were able to update visualizations in near real time when it was critical to do that, say for hurricanes or moving weather systems, flooding that could be happening at the moment. So I thought, well, that sounds tricky to do, and I'd really like for these people to present to us how they do that. And so today, that's who is presenting. And Allison, if you're ready, you can take the screen. And I'll stop sharing.
Okay, thanks, Sharon. I'm gonna share. I'm gonna remember to pull out the participants window, so hopefully I'll notice if anybody raises their hand. And the chat window, but if I don't notice you and you're trying to get my attention, feel free to unmute yourself and chime in if you just need to grab it. Thank you, Sharon, for that really informative introduction. I think you just covered a lot of what I was going to say to begin with. My name's Allison Appling. I'm in the Water Mission Area Data Science branch at USGS, and talking today about work that a team of maybe 5 to 15 of us at a time have been involved in building these data visualizations for a variety of topics, all having to do with USGS research or data products. We've been working to build our capacity to do that increasingly quickly and responsively to events, and also a little creatively. So today I'm going to talk about all of those pieces and what we think we've learned so far. Thanks again for being here. I'm looking forward to your thoughts as fellow data enthusiasts, data visualization enthusiasts, because this is a really cool, exciting topic to be involved in. So I'm actually going to start by hopefully, nope, I didn't do it. Hopefully jumping out of my slides for just a second to show you. Can you see that now? One of the visualizations that we've put together. This one was about climate change in freshwater fish, and we put together this visualization as a web companion to a research report that had just come out. And I just wanted to show you this one to get a flavor of what we think of or what we mean when we do visualizations, because there's a range of different ways that you could visualize data. When we do it, we're looking to make interactive web pages that connect users to the data and entice them into wanting to know more. So this visualization, and I'm going to skim really quickly through this, but you have the link so you can visit this more later, is talking about climate effects on fish habitat and what that's going to do to the relative distribution of walleye and bass in Wisconsin lakes. And here's the bit I had on my slide showing. I just wanted to show that you could have this chart, the static chart, in a manuscript, no problem. But what we were able to do, because it was on the web, was dress it up just a little bit. There's just a little bit of interactivity. If you slide over to a year with lots of bass, then you see more bass showing up and the floating fish on the right. If you slide over to a year with more walleye, you see more walleye showing up to the left. Kind of gimmicky, but I hope kind of fun and kind of a way to spice up the research that we're presenting. And also this interactive web page format gives us a chance to truly interact with visitors. And so here, after visitors have done some reading, they have a choice of engaging and thinking about, well, how should walleye respond to warmer lakes? What do I think they do if the lake is warmer? And they make some guess like that, and they click finished, and now they can compare. Here's my funny guess, and here's truth according to the data in this report. And so we can use these visualizations to engage directly with visitors, and as well as to hopefully get them interested in the research. And so I've said those two words a bunch just now. One thing that we think is really important and part of our mission in doing these visualizations is to complement existing USGS research. So we're part of a piece of the organization that works with and for lots of other pieces of the organization. And so we joined forces with the water use team to complement the report and the fact sheet that they put out. So that the fact sheet's on the left, with our interactive visualization represented by this movie on the right. And we think that complementing really helps get the word out about what was happening in this huge body of work that had been put together by this other USGS team. And what we were doing was trying to make it a little more accessible and a little more grabbing the attention of more people. So we think that by doing this kind of interactive visualization, what we're doing is generating more buzz, more people talking about it, more awareness of the research that USGS is putting out. We think we can reach new demographics, because if we place this web product on the web and on social media in places where lots of people can see it, then we're going to get some new audience members, people who may not have ever picked up a USGS fact sheet, but might actually really care and be excited to learn that the USGS does this kind of research. We also want to start new conversations. So if we put this out on the web, again, there are opportunities for people to engage in Twitter or Reddit conversations and dig into the questions that might come up that have to do with this science. And that gives USGS a window into what people might be thinking. It gives those new people the chance to talk with one another and with us about what they're learning. And so it's a neat way to engage with a large public. And lastly, one priority that we have as a team is to make this kind of visualization be something that we can do with relatively small investment, with not too much time and not too many people, so that we can make a lot of these visualizations, so that we can get the word out to a lot of people about a lot of different projects. And so a lot of what I'll be talking about today is what we've done to keep our investment relatively limited while still putting out the highest quality products that we can. And so I just wanted to put our visualizations in the context of other places that visualizations might land. On the very left here, we have the report that the USGS water use science team put out that reports water use in every county by lots of different water use types all across the country every 5 years. Really exhaustive report, really deep and interesting science. If you move a little bit on this gradient from deep content over to larger audience, well, they've put a lot of time into thinking about the key stories, and they put together this 2-page fact sheet that is supposed to be more accessible to a lot of people. But still, we think we can get an even broader audience if we're doing this interactive web visualization version. And so I would place our visualizations out toward the right over here as being something that can capture a larger audience at a sacrifice of not so much deep content. But we think we can still get enough out there to allow people to engage with the data and know where they can look if they want to know more. And then also, I say we make these web visualizations, but really every time we make one of these interactive web visualizations, we also coordinate and produce a social media outreach campaign to draw attention to our visualization and then to the report and fact sheet. And so we have this one main product, but we also put a lot of effort into crafting a Twitter set of hashtags and message and some thumbnail that we can put out there on the web to grab attention and bring it back to our page. Oh, and I just wanted to say that where this arrow is in between, there are other kinds of visualizations you could put in here that involve more access to more of the data, more of an exploratory, you can explore this map forever and learn all kinds of things about the data, that sort of visualization. But what we do is something that's a little more streamlined and a little more focused on a single key story that we want visitors to be able to grab. And so I see these all as options, but this is the kind I'll be talking about for our team. So I've just talked about a couple of different research companion products that we've put out, and another one that we've done, so with the walleye and bass, and then with the water use. And then we've also done one working on a manuscript release about the abundance of microplastics in lakes and rivers in the Midwest. So looking at the sources and the forms of microplastics in water and in organisms. That's one class of visualizations that we do, but there are also a couple of others. And so one of the others is current issues. So there were no manuscripts that came out with these visualizations, but we put together a couple of products that had to do with droughts, one in California, one on the Colorado River Basin. And these were really fun because they were current. They were something that was going on in the year when we made the visualization. But we had enough time that we could work with a lot of other agencies to bring together lots of different data sets and collaborate on what the visualization would look like to put together in this collaboration a really comprehensive picture of what these droughts were doing, what they looked like, how they felt on the ground. And so this is one other class of Viz products that we do. And then the last is current events, and Sharon mentioned some of this. We have been working a lot, especially on floods, because USGS monitors floods. And so for all of the major hurricanes last year, and we're looking forward to lots of hurricanes. Well, I don't want them to happen, but we are hoping to be ready for hurricanes this year. We are putting together visualizations that look something like this one for Hurricane Irma, where we can show the progression of the storm over time and what that did to precipitation and where water accumulated on the landscape, and then how that connected to what the rivers were doing. And so I can zoom in on this one, but just wanted to say that first that this third class of visualizations is really different from the first two because it needs to happen so fast. This happens in the course of a few days, and we bring together lots of people to get it done fast, whereas the others we can take a slightly more leisurely approach. So here's what a hurricane visualization can look like. One of the fun things about this is that even though it is pretty fast, we're still bringing together multiple data sources and finding ways to understand each new location as the hurricanes move from place to place. So for this one, we pulled together data from the NOAA National Hurricane Center, which gives us this storm track and gives us the dot that we can move along there as the storm center moves. We collect precipitation from a different NOAA website from the National Weather Service. We bring in the USGS monitoring data from gauges and rivers all across, in this case, Puerto Rico, and we're able to plot that both as sites on the map and then as these hydrographs of stage over time on this right-hand bar. And then to bring a little context to the hydrographs, we use flood stage information, which is documented on a NOAA National Weather Service page as well. And this says, well, above a certain line, this counts as flooding in this given stream. And so just adding that one line, if this is above or below what counts as flooding, really makes it much clearer that we hit flooding in just about every stream we're looking at here at this time, something like September 20th. So even for this relatively quick visualization, we get to work with lots of different data types and create an animation that gets a lot of looks, because it's a really hot topic that a lot of people are interested in at the moment. So for this particular example, we had about 9 people working on the project, and I want to give you a sense of the speed for us. So on Monday, we started talking about whether we would invest in this hurricane visualization or not. On Tuesday, we said, well, yeah, it could happen. Let's get ready for it and let's ask for permission. By Tuesday afternoon, we had the go-ahead, and we were going all out on producing the visualization. And this was one of our earlier hurricane visualizations. So we didn't get it quite released when it hit Puerto Rico, but we were getting pretty close. And Thursday, we were finishing up details. And by Friday, we had finished the USGS review and approval process. We had gotten the web page deployed to a public page, and we had initiated our whole social media outreach campaign, which included going to Twitter and Facebook and Reddit and usually Instagram as well. And then by Friday afternoon, we were done, and we all went home, and we had a good weekend. So when it works well, this is how we want to see it. It's a really exciting 4 days, and then it's over and we can relax. If we're going to do it that fast, we need a lot of tools to support what we're doing. And of course, to make any visualization, you need some tools. So here is a list of all of the major tools that we use. I'd say this top left category of web visualization, these are the tools that really form the basis of the visualization itself. So we build our visualizations as web pages with HTML and CSS for styling. We use SVG for graphics, and then we use the D3JS visualization library to manipulate SVGs and make them animated and make them true to the data that we're putting into them. We host our web pages through Amazon S3 and an agreement that USGS has with cloud hosting solutions with Amazon. And then we always embed analytics, and we use Google Analytics so that we can tell how many people are coming to our web page and where they're looking and what they're doing on the page. In terms of coordination, we have this collaboration section. We use Git and GitHub to share code across our team. We use one of these three tools. Sciencebase is a USGS database project, data sharing, Google Drive and Amazon S3, our proprietary data sharing products. We use Slack to share ideas across the team. And then we have a people tool. We have a project manager on every project whose job it is to keep track of everybody else on the project, make sure that we're all headed to the same goals and headed there on time, and make sure that we all have the resources we need. So having that person in that role has been a really important part of what we've been able to make work. We also really value reproducibility because we're presenting science. So it's really important to us to have the visualization be a true representation of the real data, and reproducibility of our pipeline from raw data through to the visualization is one way to help ensure that we have that scientific integrity. And so we use the R programming language to script all of our data analysis from the very first time when we download something from a public website, data resource, through to as we're preparing that data and as we put it into a visualizable form. And then I'll talk more about this tool next, but we've used a few different workflow managers or pipeline managers. The one I'll talk about today is R's package called Remake. And this is a way of saying, well, if you have 20 different R scripts, here's how those 20 scripts fit together into a single pipeline that goes from raw data to final output. Jenkins is a server system that we use to have a single controlled computing environment where we build the visualization from raw to final. And having this be a really controlled environment gives us some confidence that our product really is reproducible. It's not just that it worked on our computer, it's that it worked on this controlled system computer as well. And then efficiency, especially for these fast projects, it's really important to be able to spin up quickly and be done quickly. So one thing we've done over the past couple of years is develop a consistent project structure and set of conventions about naming and so on that allow anybody on our team to jump into a new visualization and kind of know how it's going to look. So that saves us a lot of decision-making time at the outset. And we've also developed a series of reusable templates that structure, here's generally how the website looks, here's what the header and footer look like. And then all we need to do is just plug in the pieces that are new for a given visualization. So I want to talk just a bit more about these two tools, the Remake and then Git and GitHub, because those have really been game changers for us. Those are the things that make it possible for us to do team visualizations quickly and reproducibly. So here is an illustration of what Git looks like. Git and GitHub combined allow us to share code across our team. And so the conceptual diagram on the left shows that we have one copy of the data on Lindsay's computer. We have one copy of code and data on Jordan's computer. And then we have the shared upstream repository that's the canonical place where our final code is going to live and where our best available code is living right now. And so just as a scenario to show how this works, suppose Lindsay's working on a color scheme for the map that we're building. At the same time, Jordan might be working on how we're summarizing the water use data. And so if Jordan finishes his small task, then he can push and submit his changes to the repository. He pushes them up here, and then he says, okay, I'm ready for someone else to review this. In this case, Allison, he comes in and reads through the code and says, yeah, that looks good. And I merge it into the repository. So we always have this peer review process. It could be anybody doing the review, but we always have two eyes on any bit of code that we add. And because we're using Git and GitHub, Lindsay automatically gets a notification that this pull request has been merged and there's new code available up here for her to use. And she types in one line on her computer and pulls down those changes to her computer. they get merged with what she's currently working on seamlessly. And now she has the updates from Jordan. She can keep working on her color scheme basically uninterrupted, but now she's in sync with everybody else. And then the other piece of this collaborative reproducibility is that we need a quick way to be able to preview the visualization and know that what we're seeing when we preview it is a truthful reflection of the entire code base that we currently have. So if we change one piece of the code, we want to be confident that the preview we're looking at of the web page includes that change. And so here's the code line that Lindsay runs in R using that remake package to build this water use visualization. She says make water use page, and she specifies some other arguments. That's all she types, and then, oh, excuse me, remake will go through all of the files, all the R scripts, and say, okay, this one is up to date, this one is up to date, this one needs to be rebuilt. Okay, now we're completely up to date all the way through the project. Now you can preview your page. And then if Jordan makes that change and it gets merged up in the cloud, then Lindsay pulls it back down, then she can run that same line on her computer again. And this time it'll say, oh, whoops, Jordan changed the way we're summarizing the water use data. I'd better rerun that script locally to update the data. And then there may be steps after that that don't need to get updated because they were not affected by Jordan's change, which means that this one line that Lindsay had to take also doesn't take that long. So she's only going to be waiting for her computer to catch up with that one change Jordan made, and then she can get right back to previewing the map and thinking about the color scheme she was working on. So because we can make this process pretty fast to share code and stay in sync, we are able to maintain that synchronization across our team a lot more effectively, and that gives us a more reproducible product overall. Okay, so there are all the tools we use. I'm happy to talk about any of them in particular, but that's not the only fun part of data visualization. There's also the creative process. So how do we go from knowing that there's some data out there to having a visualization that captures attention and communicates something important? And so here are the 4 questions that we ask when we get going on a visualization. And the first 2 on the left are really about what can we do, and the 2 on the right are really about what should we do. So on the left, what data are we working with? What's the report being put out? What's the event and the data that surround that event that are available to us? And then also, so we learned D3 this year, and here's an example of something you can do with D3 is zoom in and out of states, highlight states, and make something online that's interactive like this. So as we learn new techniques like this, we can decide whether we want to bring those into a given visualization or not. And that informs our creative process as well, because it limits or opens up possibilities for us. And then I'm sure you all have thought lots in your own work about what's the story when you're presenting anything. What is it that you're going to present? How are you going to capture attention in terms of meaning? Why should people be here? So we answer that question by doing things like identifying key questions that we want to pose to readers. How are plastics getting into our rivers? Or maybe helping readers spot something interesting in the data that we're presenting. So if we have a map just showing the corner of California here of water use broken down by different types, we might provide a call out that says, here's what's funny that's happening in this county and why you're seeing it that way. The other question we want to ask is, what's the visual hook? And this is a question that's kind of new to me, coming from a more academic background where really the story was the one thing. But if we're making this visualization, we also want to just make something pleasing, something pretty, something that people want to look at. And so sometimes we do that just by playing with colors and trying to find something, just an exciting way of presenting a map and feel slightly new in some way. We don't shy away from using charismatic megafauna or cute birds to capture attention, whatever it takes to communicate a lot of information, but also make it a visually pleasing place to be on our webpage. And I wanted to share a few reflections on what we've learned about the creative process over the last few years. So one is that when we're coming up with those stories, we find that we really need to go simple, and we need to go simpler than we thought we were going to, or that we needed to, because as people invested in the data and the science, it's really hard to let go of all those really interesting details that you've learned. but the less complex we can make one of these visualizations, usually the more engagement we can get. So we try and really push ourselves toward very much distilling the data and the story that we're trying to tell. We've also found that it's hugely powerful to collaborate on the creative process with 3 types of people. So we want to bring in people with domain expertise, people who know the data or the research. We want to bring in people who can answer that question of what can we do, who know the technical availability of data and the tools that we have at our disposal to build a visualization. And we also want to bring in expertise or information that we have about how outreach has worked in the past with this kind of product, because it's different from other kinds of products. So by using the information we're getting from all those web analytics and the conversations we've had with people about our visualizations, we can learn more each time about how to do outreach well. So if we bring all 3 types of expertise into a room as a bunch of people together, and then say, okay, how should this visualization look? Then we often get some of our best answers when we're all there together brainstorming. These last 2 lessons are in conflict with one another, and that's okay. It's just that we need to find a balance between them in every new visualization. So the first thing, stay focused. We need to do that because we need to be efficient in how we're building visualizations. And one way to do that is to understand and agree on the goals early on. So a visualization that presents all of the details from a report, but does that in a web interactive sort of way, is really different from a visualization that draws readers or visitors' attention to specific points and stories within a data set. And so if we can agree on what kind of visualization we're going to put out, that helps. And if we can agree on whether we're looking for capturing the attention of every congressperson versus capturing the attention of as broad an audience as possible versus going for just managers, something like that, that also helps us have conversations about how the visualization should look and how it's going so far that help us stay focused and be efficient. And on the other side of those scales, we want to be flexible because this is a creative process and we don't know all the answers to begin with. And sometimes it's only by playing with the data that we learn much about what the best ideas are going to look like. I just saw maybe a hand up. No, I think that's just okay. I think I'm good. But if you are trying to get my attention, let me know. Okay, so we want to stay focused. We want to be flexible. How do we do both those things? Well, the other piece of being flexible is we can get better and better at making quick prototypes of ideas that might go into a visualization. So we now really encourage one another. If we think we have an idea and we think it's going to be awesome, before we start building that into the main visualization, let's just draw it out on a napkin. Let's put it up on a PowerPoint. Let's try it out in some separate sandbox to see if that code idea is going to work well or not. And then we can have the conversation based on that quick investment about whether that's going to be a good idea that we want to push forward or whether, well, yeah, it was worth exploring, but we're done now. And so prototypes has been an important piece of being able to stay flexible through a process. Okay, and then the other thing that we really focus on these days is outreach. And one thing we've learned about outreach is that many of our visitors, more than half, sometimes up to 80% of our visitors to our web visualizations are on their mobile phones. So here we are developing the visualization. It looks great on our desktops where we're doing our work, but actually what's really important is how it looks on a phone. Does it load fast enough? Can you interact with the graphics on a mobile phone? And so since the first two visualizations, we really learned that we need to put mobile first in our priority list and be constantly checking to see if it's doing the things we need it to do really well. We've also learned about the importance of thumbnails and metadata embedded in our website. So it's pretty simple to do this. You just add a bunch of tags to your HTML at the top of your HTML page. And what this means is that if someone goes and copies the URL from our website and pastes it into some social media forum like Twitter, or here's a Slack one, then all they have to do is paste that URL and they will, because of these tags, automatically get a good English title, they'll get a description of the visualization, and they'll get this nice thumbnail that we had a chance to pick out because we thought beforehand about what these tags should look like. And so we have the chance to present ourselves well and to help other people present us just by copying and pasting a URL. And so now we're getting pretty good at doing that all the time because we see how valuable that is. And lastly, I mentioned that usually one project actually has a few different products. So we have the web interactive visualization. We also have a Twitter card. And so a national map, the interactive version of this, you can click on any state and zoom in and look at water use by county in that state or by category. And here are the Twitter cards for the country. So USGS as a whole can send out this Twitter card here. But because we already built this, we were in a good position code-wise to also build a Virginia map and an Idaho map. And that allowed us to share those links with water science centers across the country and say, here, you can share this with the people in your state. This is the part of the visualization that's most relevant and exciting to the people that you are working for. And several of the water science centers jumped at this particular opportunity and did post the Twitter card for their state, which gives us more ways of reaching out to more people and grabbing attention. So I say all these things like they're going to work. We don't actually know that until we look at the numbers. Here are some results from the Hurricane Irma in analytics that we looked at afterwards. So Google is helping us track how many people actually visited our page, how many came from Twitter versus Instagram versus Reddit, and whether on each of those forums people were liking it or sharing it or having a conversation about it. For Hurricane Irma alone, we had more than 500,000 views, which is pretty good for not actually being original science. We were just pulling together data sets that the USGS and NOAA had already put together. But because it was such a relevant topic, and I think we did it in a pretty good way, then, for an investment of a few days, we were able to get a lot of looks and a lot of awareness that USGS collects data that's relevant to hurricanes. And so we were pretty excited and encouraged by this kind of result. We also want to look at, is it worth our time to post on Reddit? Well, yeah, in this case, it really was, because 400,000 visitors came from one Reddit conversation that just blew up. People wanted to talk about it on that particular Reddit thread, and more people liked it, so more and more people saw it. You never know where that's going to happen. It could happen on Twitter next time, so we like to keep track of what is happening where. But overall, the message that I'm taking from this kind of analytics report, and we get these for each of our visualizations, is that this is really worth doing. We're getting a lot of looks. They're small, but that's our goal. Our goal is to reach lots of people in a quick way, and I think we're doing that. So I'll use that slide as a way to support this first assertion that we are increasing the reach of our science by presenting our data in this other way, in this new and publicly accessible way. We really, on our teams, value reproducibility, and we have these tools and these systems that we've identified that really help us do that. And it's not just the tools, but also having a set of goals and talking about them and working really hard to include a lot of people in the creative phase and the code development phase of our visualization. All of that is what helps us put together the best product that we can. So I think that Sharon already shared this link, but down here is a link to our webpage where we have all of the visualizations that we've done in the past few years. Happy to have your thoughts on any of those or anything I've said so far. And thanks for listening.
Thanks, Allison. Great presentation. Open for questions. Anybody have questions, discussion, ideas? And if you are muted, we haven't muted you, but if you are muted, take yourself off mute.
Not a question, but just a comment. Thank you very much for the presentation. It was a lot of tools and things that we've seen, I've seen in applications are being used here, and is, I think, a very good summary in this presentation. So thank you for taking the time to present.
Likewise, I really appreciate the presentation, and it was a good point to highlight also the need to consider what happens when people copy paste a URL. That's something we hadn't thought about yet, and tools we're developing for Fish and Wildlife Division at the council. So it's a great idea to be able to control how that URL appears in text and what image.
Yeah, it's a quick win.
Thanks.
We also appreciate the comprehensive nature of this and your articulate reporting of it. Thank you very much.
Allison, I have a little question on a point of detail, Sharon here. Back in one of your slides, you talked about different audiences and how you could reach people who needed the data and researchers, technical scientists, but also you wanted to make sure the data was accessible by many different audiences. And we've had some discussion in this group about who is our audience and how do we reach different audiences and multiple audiences. Back in that slide, was that a slide for your concepts, or is that in your actual data visualization where someone can choose the level of detail for their data?
I'm trying to think which slide this might have been.
About in the first third of the.
Okay, we have not made a single visualization where multiple different views are possible.
Mm-hmm.
That is an interesting idea. We have generally, I guess here,
there.
We think about this spectrum, and other people on the water use team that we were working with made this 2-pager, which is kind of targeted at someone who has some time and wants to invest in learning more about it, maybe before jumping into the full report. I think somewhere in here where this arrow is where some of those other versions could fit in. If you want a decision support system, that's going to take a lot more investment. It'll target a smaller audience, but it could be a really important audience, and could also be web-based. So I think there's lots of room in here that should get filled that our team just doesn't do.
Yeah, thanks. And you highlighted prototypes and flexibility, which means possibly iterations of your work. And we've seen that before too. We people who are working towards effective data visualizations are having to realize that's important. What was new maybe is the considerations about mobile data and social media. Do you find that that's a big time investment?
It is time. Yeah, I mean, I think we're getting better at it, so that each new time we do a new Vizi, we have to put less time into that specifically. But sometimes you got to think about what the interface needs to look like, because it just can't be quite the same. So here in this example, we're seeing this: how do you interact with the guessing game, where you're supposed to scroll past it, but you're supposed to click and drag a state into where you think it ranks among all the other states in water use. And that requires a different set of taps and clicks and things on mobile than it does on desktop. So we definitely did some iteration and brainstorming on that to try to figure that out. And you can see we also we flipped the orientation of that ranked bar chart. It's horizontal over here in the desktop, and then it's vertical over on the mobile version. So you can put in a huge amount of time on that kind of thing. And yet it really seems to be worth it, because so many people are coming to the mobile version of the map, of the visualization.
Yeah, thanks. Other questions or thoughts?
Hi, Allison. This is Monica from NOAA Fisheries. What programs are you using for the visualization that you're producing?
So yeah, I kind of made this huge list here, and hoping that because you have we use R to do the data preparation. Sometimes we use R to make SVGs, and that's just because we're so at home in R in our other lives that's kind of how we like to operate when we build text things like SVG. Support vector graphics are a really nice, clean way of presenting drawn things, like lines and dots on maps. And so So that's what we use most of the time there. We've explored using Canvas as well for some visualizations where we really need the speed of Canvas is more raster based. It can be faster to render. So in terms of graphics, that's what we're using is SVG or Canvas. And then we've been using D3 for the last year or so in order to manipulate SVG. Yeah, are there other tools that I forgot to mention here that you'd like to hear about?
Have you ever used Tableau for any, or experience with Tableau, doing any visualization stuff?
Yeah, so I've dabbled in it. I think that for us, it was easier to come up with scalable versions of our our visualizations. Without paying Tableau more to do the hosting, we can reach a whole lot of people this way for pretty cheap. And we also have a huge amount of flexibility. I know there's quite a bit of flexibility in Tableau as well and how you present data, but this gives us total control over what our web page looks like. So this is our set of tools of choice right now. But I know a lot of people are looking at Tableau as well.
Okay.
Yeah, another piece of software that I don't see on there is Esri Story Map, and people are using that. I guess super simple to use and put together some kind of a story. Allison, do you see a use for Esri Story Map? Maybe just because of its simplicity?
So yeah, absolutely. I mean that happens to not be what our team does because we want to specialize somewhere. But we have collaborators down the hall in Wisconsin. I live in Pennsylvania, but lots of my team is in Wisconsin. And just down the hall from them, there's the whole web internet. I think it's called Web Internet Mapping now. WIM organization is part of USGS, and they focus on story maps, and they make glorious, beautiful, really informative story maps that put together data and maps and time. And that's just not what we do. I think that fits a little bit more over here. You have greater capacity as a visitor to find some of the stories on your own, but also can be nice and guided. So just another tool set that we should be using somewhere in the USGS and maybe in your organizations too.
You said it's WIM in in Wisconsin? Trying to find
Yeah, they used to be Wisconsin Internet Mapping or something, or Informatics and Mapping. I've just forgotten WIM.
Okay. I might post them as a resource also.
Yeah.
Well, thanks. More questions or ideas? I think I have one last question, Allison. That is that if someone's developing, one of us is developing a data visualization, is there someone in USGS who we could contact, either you or somebody who's working, to just bounce some ideas off of or ask questions about a given tool or how you put together a given visualization?
Yeah, absolutely. I mean, I think for small amounts of investment, we really love talking to anybody and everybody who's involved in presentation of science. So if you contact me, Jordan Reed is the other one you mentioned, or Lindsay Carr. I think she didn't make it on the phone call. She had stuff going on today, but any of the three of us would be happy to field a question and or send it to someone else on the team.
All right. Good to know. And I'll have your contact information posted on our pnat.org site. Great. Later. So any more questions or thoughts for Allison? Well, thanks. Anybody can chime in at any time. And I think, Allison, if you give the screen back to me, there's just a couple more things to talk about.
Sure thing. Thanks all for your time.
Thank you very much. All right, everyone. So as a working group, I just wanted to make a quick little plea for your ideas about what you would like to see presented. And I've been asking all along, but I'd like to see what your thoughts are now that you've seen about, I think about 6 or 7 presentations. And those are posted and videos are posted too on the Google Drive. We don't have room on pnat.org for videos, but on the Google Drive there are videos. So as a working group, I'd like to make a plea for a little bit of participation. Ideas, people who might be doing data visualizations within the monitoring community, aquatic monitoring community, or outside would be great too. I am talking to some U.S. Fish and Wildlife people and a few other people, but yeah, any input would be really welcome. And then at this point too, I wanted to know how everyone is feeling about where we're going with this. It's feeling sort of like a slow-moving conference where we're seeing presentations and we're able to talk and ask questions about them, but we're also building some resources we can use later. But I'd like to know if everyone is liking the format as is, or if we might want to change the format and do something a little different. For instance, we can get into exactly how to use tools, which tools, into the technical aspects, or we can go in a different direction and how to talk about the creativity, how to come up with a data visualization, the stories, or what might work. So any input, you don't have to speak now, but if you can email me and let me know, that would be good too. So any discussion now about where we're going, what we'd like to do with the group in the future? All right, then, pretty quiet group. So I'll ask again through email and see if I can solicit a little bit of feedback. And I think we can end early if there are no more comments or thoughts about the group. And I'll also be emailing the wider group. There are about 60 of us in the group, and about maybe half of us attended. If you have colleagues who attended or you think might be interested, let me know who they are and I'll add them to the list. And so I'll be asking these questions through email as well, and we'll go from there. So any last thoughts?
None. Thank you, Sharon.
Thank you very much, Sharon.
All right, everyone, we'll say this is a wrap, and thank you very much for attending. I'm glad to see such a large group, and Allison, and thank your colleagues, Jordan and Lindsay. Allison, great job, and I really appreciate your time for showing us what you're working with.
My pleasure.
Have a good day, everyone.
Thank you.
Thank you.